Hey everyone, and welcome. Today, we're going to talk about a type of chemical reaction that's basically a big partner swap. It's called a double displacement reaction. And I know it sounds super technical, but trust me, it's way more fun and way easier to understand than you might think. So let's just jump right in.
So here's the big question, right? What actually happens when two chemical compounds just decide to switch partners? Think of it like a dance floor. You got two couples dancing, the music changes, and they swap partners. The results can be, well, pretty dramatic and super cool to watch. So let's figure out how this whole dance works.
Okay, so our first section is called a new relationship. And you know what? That is the perfect way to think about this. We're literally watching brand new, stable chemical relationships or bonds form between completely different elements.
All right, let's get the official textbook definition out of the way. What is a double displacement reaction? Simply put, it's when two different compounds exchange their ions to create two totally new compounds. So picture it again. You've got two couples. Each couple has a positive ion and a negative ion. In this reaction, they just trade. The positive from couple A goes with the negative from couple B and vice versa. And poof, two new couples. It's really that straightforward.
Okay, so now let's get a little deeper into the mechanics. Our next section is all about the exchange of ions. This is where the magic really happens. We're going to see exactly how this partner swap goes down at the atomic level. It's all about that classic attraction, you know? Positives and negatives just can't stay away from each other.
So you can think of this whole thing as a four-step dance. Step 1, our two compounds meet up, usually when they're dissolved in water. Step 2, their positive and negative ions break apart, and they're just kind of floating around freely. Then comes step 3. This is the big moment. The ions swap partners. The positive ion from the first compound grabs the negative ion from the second, and the other two do the exact same thing. And what's step 4? Boom! Two brand new compounds are formed. It's such a simple, elegant process when you break it down like that.
All right, talking about it is one thing, but seeing it is something else entirely. So for this next part, let's head into the lab, so to speak. We're going to watch this chemical dance happen in real time and see something totally new get created right in front of us.
Okay, let's set the stage. We're in the lab. First up, we've got a beaker with a totally clear liquid. This is a solution of sodium sulfate, or Na2SO4. Right now, not much to see. Now we're going to introduce our second dancer. We're adding another clear solution, and this one is barium chloride, BaCl2. So, what do you think is going to happen when we mix these two perfectly clear liquids? Any guesses?
Whoa, look at that! Instantly, a white solid just appears. It looks like magic, doesn't it? The whole solution turns cloudy. This solid has a special name. It's called a precipitate. And that right there, that's our proof. It's a brand new substance that won't dissolve in the water. This is our reaction, live and in action.
Okay, that was awesome. We just saw the magic happen. Now, let's translate that into the language of chemistry. It's time for the story of the equation.
And here it is. This is the chemical equation that tells the whole story of what we just witnessed. We have sodium sulfate plus barium chloride, and that gives us barium sulfate and sodium chloride. Now look at those little letters in the parentheses. See the AQ? That just means aqueous, or dissolved in water. But the really important one is the little S next to barium sulfate. What do you think that stands for? Solid. That's our white stuff, the precipitate we saw form.
This table makes it super clear, right? It's like a before and after. Before, you had couple 1, sodium with sulfate, and couple 2, barium with chloride. Then, after the reaction, look what happens. Barium has swapped over to be with sulfate, that's our solid. And sodium has paired up with chloride, and they're just handing out dissolved in the water. It's a perfect, clean swap.
Okay, so we've covered a lot. What are the most important things you need to walk away with? Let's wrap it all up with our key takeaways. So how can you spot one of these reactions? It's pretty easy if you know what to look for. Here's a little checklist for you. First, you're always going to start with two compounds. Second, you know there's an exchange of ions going on between them. Third, you'll always end up with two completely new compounds. And, the biggest clue of all? Often, you get that precipitate, that solid that just appears out of nowhere. If you see all those things happening, chances are you're looking at a double displacement reaction. Easy peasy.
And that kind of brings us to the end. Now that you get the idea behind this chemical dance, I want to leave you with a question to think about.